test example 2. This time we'll do one that's one-sided. Does ownership of an e-reader, such as a Nook or Kindle, increase after the holidays? A publishing company wants to know in order to plan its advertising budget. Based partly on conventional wisdom and partly on combining results from various studies, the publisher believes that in early December 2011, about 10% of Americans owned an e-reader. In January 2012, after the holidays, the Pew Research Center conducted a survey of 1,377 randomly selected adults and found that 19% of them owned an e-reader. Using a significance level of 0.05, carry out a hypothesis test that will test whether the proportion of Americans who own a Kindle will increase after the holidays. So let's do our hypothesis test. Step 1 is to state your null hypothesis and alternative hypothesis. Now, for this example, our P is the proportion of Americans who owned an e-reader in January 2012, or after the holidays. And we want to know, based on this study, can we conclude that P is actually bigger than 0.10 or 10%? So our null hypothesis is that 10% of Americans own an e-reader, or P is 0.10. The alternative hypothesis is that more than 10% of Americans own an e-reader after the holidays, or 0.10, or P, is greater than 0.10. So null hypothesis is that we just have the same percent of Americans who own an e-reader after the holidays as before, and then alternative hypothesis is the number has increased. So we have more. The proportion of people who own an e-reader after the holidays is actually bigger than 0.10, how much it was before. So step 2 is to get ready to test. So in this step, we state our significance level and we check the conditions. Our test statistic for this type of test we're doing in 8.2, it's always the z-test statistic that we have the formula for. You don't have to worry about that part. So significance level we're given, that often happens. We're told to use a significance level of 0.05, so you guys don't have to do anything about deciding what it is. And for checking the conditions, we just have to go through all these conditions in order to do the steps that we take after this, in order for them to be valid. Okay, so step 2, checking the conditions. First step is random sample. We need to check that our sample was random. Now, we are told this. We are told that we Pew Research Center conducted a survey and selected 1,377 adults at random. So randomly selected, you can see it within the text. For large sample size, you are always going to be checking that n times p naught is bigger than or equal to 10, and n times 1 minus p naught is bigger than or equal to 10. So both of these have to be bigger than or equal to 10. Now the important thing is that you plug the right numbers in here, and our n is the number of people we've taken at random. So randomly selected people, that's what n is, the sample size. And p naught is your null hypothesis proportion. So the sort of like typical, like no change guess. It would that's our null hypothesis proportion. So if we plug these into these two formulas and put them into our calculator, we end up getting 137.7 and 1,239.3. And both of these are bigger than 10, so step 2 checks out. Now, if you want to know what these numbers represent, so like, what is this and what is this? Well, n times p naught is the number of our randomly selected people who would own an e-reader if the null hypothesis were true, or if there were 10% of the people owned one. So we would have 137.7 about. And then n times 1 minus p naught is the number of people who do not own an e-reader if 10% of them owned an e-reader out of the 1,377. And so that would be this number here. These both have to be bigger than 10 or equal to 10. Okay, large population. So we need to check that the population is at least 10 times larger than the sample. In other words, we have to check that 10n is smaller than the whole population of all Americans in the world. So n, remember, is 1377, and so if we multiply that by 10, we get 13,770, and this is definitely smaller than the number of Americans in the world, so we do satisfy condition 3. So condition 4, independence. So we need to check that each observation or measurement must have no influence on any of the others. Now, this is something that we're going to assume is true. We're not told it explicitly, but we're going to assume that the pollsters surveyed people in such a way that their responses were independent of each other. In other words, each of the individuals who were polled, they didn't influence each other's decision to buy an e-reader. Okay, now we need to prepare. So under prepare, we are supposed to state any assumptions that must be made. And in this case, what we just did just now is we made an assumption. And that often with the conditions, if you're not explicitly told something, you need to make some kind of assumption that things are true, unless it's like so obvious that the conditions are not met that you can't make the assumption. Okay, so just a quick summary if you want to pause on here. These are the conditions that we checked, and you can take a look at this if you want to just like review what conditions we checked. Okay, so now we can get to the computational part of this. So step 3 is figuring out what our p-value is, and we're going to do it this time just using StatCrunch. In the previous video, I showed you guys how to do it with a combination of StatCrunch and by hand, so you can go back to doing it that way if you're curious, but in this one we'll just use StatCrunch. So what we do is we go stat, proportion stats, one sample with summary, and then this box that you see on the right is going to pop up, and we just have to know what we're supposed to fill in to various spots in the box. So under number of successes right here, number of successes is the total number of people interviewed who owned an e-reader when we did our survey of the randomly selected population. So we randomly selected 1,377 adults and found that 19% of them owned an e-reader. So that means that the number of successes or number of people who owned an e-reader was 19% of 1,377. You have to actually calculate it in this case. Sometimes you're told the actual number, but in this case you have to calculate how many by doing 19% of 1,377. Now if you do that, you want to move the decimal 2 places to the left to get 0.19, and then you multiply it by 1377, and then we get 261.63. So this is the number that we're going to put into this box here. In fact, we'll probably round it to 262 people. And then number of observations is just the n value, so like how many people you surveyed. And then we're going to have to fill in this box for right here, for our p naught value. So our null hypothesis is that p is equal to 0.10. We saw that earlier. And then we're doing a one-sided alternative hypothesis. In other words, we want to know if p is bigger than 0.10 for our alternative hypothesis. So we have 4 things that we have to adjust in this box once we go to StatCrunch. So I'm going to show you guys how to do that now. So here we go, stat, proportion stats, one sample with summary. And this is the box I was just showing you on the slides. We fill in 262. I've just rounded the number that we got over here. I'll show you guys. So this is 261.63. And I'm just rounding it to 262 to make it make more sense because this is number of people. And then we put in 1377, that's number of people we surveyed, and we have this checked already. It's hypothesis test for p, so we're trying to make some prediction about the likelihood of various things for p. And then we plug in 0.10, that's our null hypothesis, and then I have to change this to p is greater than 0.10 because we want to know, did the number of e-readers that people owned go up? Was p bigger than 10% after the holidays? And then we push compute. And so now we go over here. Now this has a bunch of numbers of interest. We can have our standard error, which you guys have a formula to calculate. We have our z-stat or our z-test statistic, and that is right here. And then it tells us our p-value, and often if the p-value is really small, you're going to see that it's less than some number, and in this case this happens again, just like the last example. And so we're going to go back here. Ooh, that's weird. I'm going to go back here and look at our result. Okay, so this is what popped up on StatCrunch. And we can see that our p-value is smaller than 0.001. And what we're going to do is we're going to compare it to our significance level, which was given. Our significance level was 0.05, and we want to know which number is bigger. Now, in this case, our p-value is smaller. 0.001 is smaller than 0.05. So, like, our p-value is not 0.001, but it's smaller than this. And since 0.001 is smaller than 0.05, then we definitely have our p-value is smaller than 0.05. This means that we reject the null hypothesis. So remember, if the p-value is smaller than your significance level, you reject the null hypothesis. So in step 4, we want to make a decision. Do we reject the null hypothesis or not? What does this mean if we reject the null hypothesis? This means we're going to conclude that the proportion of Americans who own a Kindle will increase after the holidays. In other words, the null hypothesis was that the proportion of Americans who own an e-reader just stays the same after the holidays. But since our p-value was so tiny, we're going to reject the null hypothesis and say that the proportion of Americans who own a Kindle is actually going to increase after the holidays.